Hello everyone. Welcome to today's webinar on Simulink Copilot and Generative AI for model-based design. I'll walk you through how you can bring the power of Gen AI into your work with Simulink and accelerate your workflows. Before we get into the specifics, let me first introduce myself. My name is Tian Yi. I'm a product manager at MathWorks, focusing on integrating generative AI and agentic AI into Simulink. In today's session, we'll first start with what's the latest with Gen AI in the field of engineering, and then we'll dive into two ways for you to start using Gen AI and Simulink: Simulink Copilot and Simulink Agentic Toolkit. Towards the end, I'll share resources for you to learn more about Gen AI solutions with MATLAB and Simulink. We've also set aside some time for you to ask questions, so let's get started. What's happening is that Gen AI is transforming the way engineers work, and the way of developing engineered systems is being reimagined. It's one of the most profound technology shifts in our lifetime. It can generate code in seconds, it knows how to use different software tools, and it has a deep understanding of engineering concepts across multiple domains. That combination has unlocked a level of productivity increase that nobody has ever seen before, and it all happened in such a short period of time. Gen AI is great at creating things fast, but complex engineering isn't just a creation problem. The systems that you develop have to be safe, have to incorporate components from multiple domains, and interact with the physical world. So these aren't limitations of Gen AI. They are the reason why trusted engineering tools become more important when AI becomes added into the loop. And one of the most frequently voiced concerns that I've heard from many customers and from many of you is that when you speed things up with Gen AI, errors compound quickly. You want to build faster, but on top of a foundation that still guarantees high quality. And the core idea here is that you don't have to choose between speed and quality. You get both by combining generative AI with model-based design. Model-based design already gives you the quality framework. Models are executable specifications. You run continuous verification to catch errors early. You have traceability all the way from requirements to your models and to your generated code, certifiable code generation, and more. So that's the foundation. It's what makes Simulink the standard for developing safety-critical applications across many applications. What generative AI adds here is speed. It helps accelerate the parts of the workflow that are manual and time-consuming. Tasks that used to take hours or days now take minutes. We are enabling generative AI with Simulink to meet you where you are, and it's done through two offerings. On the left, we have Simulink Copilot. This is an AI assistant that's optimized for Simulink. Copilot responses are grounded in the open model as well as MathWorks documentation. In R26A, we're shipping features like helping you explain the model and help you resolve errors within your models. So it's really a conversational assistant that's built directly into Simulink. And I have some demos on these features later. This is a licensed product that has been released in R26A. And we're adding more capabilities in future releases. On the other hand, we have Simulink Agentic Toolkit. So if you're already using an AI coding agent, like OpenAI Codex or GitHub Copilot, we have released this to equip your AI agent with the tools and expertise to understand, change, and verify Simulink models. This is available now as a GitHub repository. So you might wonder which one fits you the best. And the answer to that question depends on your specific use case and your setup. If you want to stay in Simulink and you like having Copilot assistance right at your fingertips, Simulink Copilot will provide the best integrated Gen AI experience within Simulink. If you already have access to a coding agent and want to integrate it with Simulink, then the Agentic Toolkit helps you connect Simulink into your existing Agentic AI workflows. The toolkit is likely the fastest route to help you get access to agentic capabilities, features like model modification and creation. The toolkit supports releases going all the way back to R23A, so that most of you can start evaluating and experimenting right away. On the other hand, Copilot is available starting from R26A, and we're working on enabling fully agentic capabilities in Copilot. But Copilot does provide one important benefit, and we're calling it no context switching. And this means that you stay in the Simulink editor that you are already familiar with, and you don't have to leave and constantly reach out for information from an external agent environment. Another important benefit of Copilot is that it's a product that you can use right out of the box with almost no setup required. We've also put guardrails in place to make it really focused on Simulink tasks. Whereas the Agentic toolkit is highly flexible. You can bring your own agent and large language model infrastructure, but the setup process does require you to have some baseline understanding about AI concepts, things like MCP and skills files. I want to start with Simulink Copilot. This is a new product that we launched in R26A to bring generative AI into Simulink and model-based design. And the high-level vision for Simulink Copilot is for it to be an expert AI assistant that can help you boost your productivity across the entire lifecycle with model-based design. You can think of it as a knowledgeable teammate that understands Simulink models as well as different tools from the Simulink product family, one you can chat with and you can learn from. We know that for any kind of Copilot product to be useful, it cannot just be yet another generic chatbot. It has to deeply understand your work. R26A will help lay the foundation for understanding, and this means that Copilot has deep insights into your models, and the responses are grounded in MathWorks documentation. For R26A, Copilot's main capabilities are focused on explain and advise. You can use Copilot to learn tools and techniques that are specific to your tasks. You can generate explanations for a model as well as its components. You can use natural language to search for specific components inside your model and get design advice on how to refactor existing logic or create new designs. You can also use Copilot to troubleshoot errors, whether they come from simulation or code generation. So now let me step you through some demo videos to show how Simulink Copilot works in action. So on the left, you have an open model showing a battery management system. On the right is the Simulink Copilot chat panel. You can use this panel to ask questions about tools, about modeling techniques, or design tips. For example, I can ask Copilot, what are the tools to use for detecting dead logic in Simulink? So Copilot is going to look through relevant information, and it's suggesting a combination of options for checking that logic, including using Simulink Design Verifier, a set of checks from Model Advisor and Simulink Check, as well as Simulink Coverage. So I can click on the documentation link to go directly to the doc page, in this case, Design Verifier, to learn more about how this can be done within that specific product. Another use case is using Copilot to understand models. And this is especially useful when you're looking at a model that you've never seen before, whether you are a new hire who's trying to ramp up on a model, or you've just taken over a model from another team that worked on it. So I can ask Copilot to walk me through this model at a high level. So Copilot first thinks through this query and plans its approach with a visible reasoning process. And this is the gray text that I'm highlighting here in the blue box. And this has given me a clear view into how Copilot is approaching the problem behind the scenes, which also makes it easier for you to understand what are the steps that it's taking, and you can steer Copilot with better follow-up prompts if you don't get a satisfactory response on your first try. So after the reasoning process is complete, Copilot will retrieve model information and generate a structured walkthrough of this model. The response has links embedded in it. And you can use these links to hover over them to trace to the corresponding elements in the Simulink editor. And you can also click on a link to highlight a model element and navigate directly to it. And if you want to drill down into a particular subsystem, you can right-click on a block and use the Explain with Simulink Copilot option in the context menu to drill down more into this particular component in a model. And this launches a new query in Copilot and gives you a more scoped analysis on just that block. And again, with the links provided in the response, it's really easy for you to navigate and discover model elements within the subsystem, whether it's the thermal model or it's the battery plant model. In addition to explaining your model, you can also use Copilot to do natural language search. The idea is that instead of manually digging through your model, you can ask Copilot to find whatever you're looking for. For example, in this case, I can ask Copilot to identify the state of charge estimation algorithms implemented in this model. So Copilot goes through the reasoning process again and points out 2 places where this is implemented, both at the top-level BMS algorithm level as well as in the battery plant model. And I can use the links to quickly go to these places and identify the corresponding logic. And towards the end of the response, Copilot also provides an explanation, and that's helping you contextualize how each algorithm is implemented and its specific purpose within this model. And if you're looking for more detailed responses, there is a special mode that we've created for Simulink Copilot, and we're calling it Deeper Insights. So this mode uses a more powerful AI model in the back end. This does come with a cap on the usage. And you can hover over the Deeper Insights button. And to enable it, you can toggle the button on, and it turns blue. And then you can click Send. So we've designed Deeper Insights to be best at handling complex design questions. For example, I can ask Copilot to describe the equations of the state of charge algorithm in more detail. And with this mode enabled, Copilot generates detailed equations describing how the algorithm works, both at the BMS algorithm level and at the battery cell level. And now that you've established a baseline understanding of your model, it's time for you to make a change. You can use Copilot to zero in on exactly where a change is needed and get actionable advice on how to make that particular change. So in this case, I can ask Copilot to implement, how can I implement a spike in the ambient temperature of the battery? And I'm asking it to point me to where in the model that I can make the change. So Copilot reasons through the request and navigates me to the exact location, which is a constant block that implements the temperature value. I can highlight it in the canvas. And as the next part of the response, Copilot also lays out concrete implementation steps, offering me with different design options, such as replacing the constant block directly, or there are 2 other options that I can use. Another goal of ours is to bring Copilot assistance to wherever you need it. So let's say I have a battery plant model open, and I click on the Run button to run the simulation, and I've encountered an error. What we've done is that we've built an Explain button directly into the diagnostic viewer message. So that's the twinkly star icon that you're seeing here. And clicking on that button launches a new query for Copilot to explain the error and suggest a possible solution. In this example, Copilot explains that the issue is a data type incompatibility problem. And then in the next section, it offers options for some quick fixes. So this enables you to resolve the issue right where the error occurs. No copy pasting required, and this leads to faster troubleshooting. So that was an overview of the main capabilities for Simulink Copilot, an AI assistant that's built into Simulink, available starting in R26A. Now, let's switch gears and talk about Simulink Agentic Toolkit. But before I dive into the details, I want to step back for a second, because the toolkit makes a lot of sense once you understand the shift that's driving it. What's happening in the last 6 months is that we've moved to a world where AI agents become capable of operating in a loop with real engineering tools. We call that the agentic loop that you're seeing here. The agent takes actions, it uses tools, it gets results back to you, and it iterates with you like a true design partner. What's important is that the engineer stays in control. You set the intent, you review results, you make the final call. Some of you are already experimenting and using AI coding agents for your daily work, like GitHub Copilot, Cursor, or Codex. We're seeing that the AI model providers are standardizing on MCP, which stands for Model Context Protocol. And this is becoming the main interface for AI agents to interact with tools like MATLAB and Simulink and enable agentic automation. In response to the rise of MCP, we released MATLAB MCP Core Server to connect your AI agent of choice to MATLAB so that it can operate MATLAB as one of its tools. But for the AI agent to be truly effective at using MATLAB and Simulink, it needs not only the connection, but also domain-specific tools and knowledge. And this means giving the agent a set of tools for Simulink-specific tasks and a catalog of skills teaching the agent how to best apply these tools for specific workflows. And Simulink Agentic Toolkit is the answer. So let's take a look at an example of what this toolkit really enables. So this is the setup. We have MATLAB running on the left-hand side and an AI agent running on the right-hand side. And here, our task is to construct a physical model of a motor. And as the first step of doing that, we can first provide the agent with some specifications of how this motor should be built and what are the parameters. And we can see that the agent is already starting to work on this query, and it's showing me its full thought process as it proceeds with this task. And we can watch it adding blocks, making connections, and simulating the model. And in this case, we're seeing that the first attempt fails to compile, but the agent is able to quickly recover from this and iterate on this problem until it finds a solution. So we're seeing that it's calling a set of relevant tools for making edits to the model and running simulations again. And it returns us the completed model with simulation results that we can look into using the scope. So what's really important here is that the AI agent has accelerated the creation work for this physical system model. But the engineer still needs to know what should be built and should understand the system well enough to know if the simulation results are correct and steer the agent to iterate on the starting point. But it really has cut down the task from taking hours to taking minutes and sometimes even seconds. So back to what is the Simulink Agentic Toolkit. It ships two things: MCP tools that are purpose-built for Simulink operations, and an expert skill catalog that teaches the agent how to use these tools well. So that combination is what lets the agent understand a model structure, make targeted changes, and verify that those changes are correct. And it works across different platforms: GitHub Copilot, Codex, Gemini CLI, or any coding agent that supports the MCP protocol. So you might be wondering, why does the toolkit matter? What we're seeing is that without guidance from the toolkit, AI agents waste a lot of tokens trying to invent their own ways of working with Simulink. They take guesses at API calls, they hallucinate block names, sometimes they break existing connections. So the toolkit eliminates that trial and error process so you can really focus on the actual engineering problem that you're solving. In general, the toolkit turns a general-purpose coding agent into a real engineering expert, one that understands Simulink and follows best practices right out of the box. So here I'm showing the full set of MCP tools that the AI agent can use to interact with Simulink. And they're organized into 3 categories: understand, change, and verify. We have tools that provide the agent with structured access to information from the model, like architecture, model composition, parameters, and variables. There is a dedicated tool for creating and modifying models. There's also a tool for creating and running test harnesses. Underneath all of this sits a skills layer. Skills are plain text files that encode domain-specific knowledge and best practices for calling a set of tools for a specific task, such as how to structure a test harness and how to make targeted changes to a model. They equip agents to think like engineers who are fully proficient in Simulink and model-based design. So here's the skills catalog from the toolkit. It has skills for requirements drafting, creating specifications before doing the implementation work, for simulating models, and testing models. And there's also a filing bug report skill that you can use to create a report if you have any issues with the toolkit. You can open an issue in the GitHub repository and attach the report to share the reproduction steps with MathWorks. This makes feedback sharing incredibly easy. An important use case that the agentic capabilities truly unlock is the automation of the troubleshoot, fix, and verify loop. So here's how it works. So when an issue is identified, the agent helps diagnose the issue by looking into the model with calls to model overview and model read. And then it will author the appropriate test, whether that's creating a test harness, defining test cases, or just in general setting up the verification infrastructure. And once these tests are in place, the agent runs the test and analyzes the results. If something fails, the agent doesn't stop there. It delivers a fix to the model by calling model edit. But what makes this really powerful is the feedback loop. After the fix is applied, the agent automatically reruns the test to verify that the change indeed solves the issue without introducing any regressions. So this iterative cycle can dramatically reduce the manual effort that's typically required in this workflow. So here's an example that shows how it works in practice. Here I have a stability control system that is buggy. I'm reporting the issue from this model to the agent, and I'm asking it to investigate into this issue. So the agent decides to use the testing Simulink model skill to reproduce the issue. And then it reads into the model to identify the pattern, the model structure, and using the information from the model to help isolate the issue. And after that, it creates a test harness for the subsystem that has the bug, runs it, and reports back with a summary. And I can check out what the test harness looks like for this subsystem. And I can ask the agent to fix this issue for me. So the agent first presents a plan on what are the steps it's going to take to address this issue. And then it's going to directly apply the edits to the model using the model edit tool and runs the test again so that it can verify this change. And then it finally reports back to me saying what's the model behavior right now and how it has fixed this issue. So what I showed you here is only one of the use cases unlocked by the Agentic toolkit. You can use the toolkit to go from a set of requirements to a first draft of your system architecture model that's defined in System Composer. My task is to let the agent build a System Composer model from a screenshot. So this is a screenshot of an example requirement set. And this can also be a Word, a PDF, or an Excel spreadsheet file. So the agent then works on parsing the file. It's going to create all the components within the system architecture model. It's going to work on defining the interfaces within these components. And it will work on wiring all of these components together to assemble the system architecture. And I can use System Composer to navigate the model that's been built and use this as a solid starting point for me to iterate on. And you might also have a legacy model that you're trying to document and add requirements to. And Agentic Toolkit makes that process a lot faster than before. So here my task is for the agent to document this legacy model that I have with requirements, as well as adding links from the requirement items to the corresponding model elements. So the agent has identified the requirement skill, and it will then call a set of tools to first inspect the model's content by using model read and model overview. And then it will draft requirements items based on what's inside of the model. And after it has gathered enough context from the model, it will work on implementation, which is linking each requirement item to the corresponding model elements. So after that's done, I can see the report provided by the agent. And I see that 26 requirements have been created, and they have been linked to the model. And I can get into the requirements view within System Composer to inspect the details of these requirements items. And I can see that all of them have been linked to different components and elements. And that's helped me add traceability between requirements and the model. So there might be another use case where you have a set of requirements and a model that implements these requirements. But not all of the links are in place between the requirements and the model. And your task is to identify the missing links and add all of them. So I can ask the agent to perform an audit on the requirement set line by line and check against the model implementation for any missing links. And I want the agent to first present a plan before it goes ahead and works on the implementation. So the agent looks through the entire list of requirements, and it generates a list of requirement items that are not currently linked. And it looks like there are 22 of them. It reports back to me with these specific requirement items with their IDs. And if I switch back to the requirements view, I can indeed confirm that there are no links for these items by looking into the property inspector. And this is the same for all of the system inputs. They're not currently linked to any model elements. It's actually a really tedious and time-consuming task for you to link all of these imports to the requirement items. But what I can do is that I can ask the agent to perform the linking for me based on this initial list. So the agent is going to accelerate the process of the entire linking, the link creation process. It's going to pull the most relevant elements from the model and identify the associated requirement items. And we can confirm this by looking into the model and visually inspecting the mapping between the requirement item and the model elements. So we see the switch precedence item has been linked, and the waiting state for long increment switch detection item has been linked to the model elements as well, and they're being highlighted in the Simulink canvas. And we see that the whole list of imports have been linked to corresponding requirement items. And if we skip ahead a little bit, we can see that all of the outports have also been documented and linked to requirement items. And for those of you who are interested in modeling decision logic, another use case of the toolkit is for generating and analyzing stateflow charts from requirements documents. So here is a Word document describing the functional requirements for an automatic gear transmission system. I can task the agent to read into this document and directly generate a stateflow model. So the agent calls into relevant tools from the toolkit, parses information from this document, and it will work on assembling the stateflow chart. So we can see that this stateflow chart has 4 states describing the gear transmissions. And what's great is that I can see this chart being built out as the agent works on the chart creation process. So we see that there are 4 gear states. There's threshold calculation being performed, and there's also implementation for safe startup. So now I can ask the agent to create a simple test scenario for me to validate the system's behavior. And the agent is able to simulate a simple scenario for the gear transmission algorithm, and it's returned the plot directly to me for further analysis. And I can read into the details of this gear shift scenario and looking into the details of the plot, which the agent has generated for me. So we covered this use case earlier where you can generate plan models using Simscape and ask the agent to tune multiple parameters to achieve desired simulation behavior. So when you're building complex systems, you can first ask the agent to create spec documents outlining the design plan before it takes on the long-running implementation work. So this helps settle key decisions earlier rather than late so that you can avoid rework or wasting a bunch of tokens. In this case, I'm building a model for a high-performance racing application. What I did was I first created the system's requirements and asked the agent to follow some implementation rules, like componentizing the system using subsystems and using simulations to compare the system's performance against real telemetry data. So the agent goes ahead and builds individual components. It even maintains a to-do list to track the completion of these subsystems. It also does the system integration work until the system simulates. And it can generate plots based on simulation data and compares it against the telemetry data for my review. With the Agentic toolkit, you can also automate simulation tasks such as generating synthetic data and using that data as simulation inputs. And this makes configuring the simulation much faster and easier than before. So here I have a sun tracking algorithm for a solar panel. I can prompt the agent to generate data, capturing the sun's movement for a 15-hour day, and route that data into the model by replacing the step block with an import. I can also ask the agent to plot the sun's position along with the solar panel's position to see how well the tracking works. So the agent calls relevant tools and presents me with a plot showing the positions of the suns versus the solar panel, as well as the tracking error. So last but not the least, you can leverage the agent to propose model restructuring plans and execute on the refactoring process to improve model readability and long-term maintainability. So the AI agent will be able to look into the model structure, simplify it, reduce nesting, and clean up model interfaces. So that's the model before, and this is the model after the cleanup. And at the end of the process, the agent provides me with a snapshot of the result. So this is a summary of the refactoring work that the agent has performed. So to summarize, we have two pathways to augment model-based design with generative AI. One is through the integrated AI assistant that's optimized for Simulink, and this is Simulink Copilot. The other pathway is connecting your AI coding agent to Simulink through Simulink Agentic Toolkit. So these solutions are designed to meet where you are, whether you want to work within Simulink or use Simulink along with your AI coding agents. To learn more about Simulink Copilot, you can go to the product page on mathworks.com, watch a short overview video, and look through the product documentation. For Simulink Agentic Toolkit, you can go to a web page and download the toolkit directly from the GitHub repository. And we provide many generative AI capabilities with MATLAB and Simulink beyond what we covered today. And all these offerings can be found on the Gen AI webpage that I'm showing here. Thanks again for joining us today. And now let's get to your questions.